I would like, first of all, to invite Dr. Myint to present about a topic called estimating the optimal evacuation route for emergency event. Dr. Myint, please.
Okay, hello everyone. Good afternoon. I'm Myint from University of Computer Studies, Yangon, Myanmar. Today, I would like to present the developed system of estimating the optimal evacuation route for emergency event. Find myself. Also, this is a part of the project title, Context Aware Disaster Mitigation using Mobile Edge Computing and Wireless Mesh Network. And in this project, this is UCSY is deploying the part of the optimal route finding system is developed. So this is a emergency for, we consider our system is for the emergency event. Emergency event can happen any time and everywhere without message or alert. The emergency situation can be caused by the disaster, such as the wildfire, natural disaster, cyclone, and tsunami, strong wind, earthquake. It can be caused by explosion, etc. But in our developing country, Myanmar, there has some fire disaster is more greater than the other disaster effect. In Myanmar, about 70% of disaster are fire. According to the data of the Department of Central Fire Department in 2021, there are 2,107 fire outbreaks are occurred. 151 injured persons and 105 are dead. And country is lost, there are 33 million deaths. And people are lost their home is 4,154. For this year, it's only the data for January to October. So it's 2022, January to October, the fire outbreak is there, 1,797 cases, 142 injured and 79 dead. Loss of their property is 320,643 million deaths. 6,352 people are lost their home. According to this outbreak of 1,797, there are some source of kitchen fire is 172, and 360 by negligent fire, and 390 cases by the electronic circuit problem, and 712 by arson. 131 is case by fire, forest fire, and other SF fire is there 26. In this, according to in this data, in city of Yangon, Myanmar, is 181 outbreak of the fire is lost there 947 million. Because it's metropolitan area in Myanmar have the complex road network structure. The complex road network structure can case delay the driver and can increase the damage level. Example, closed road, narrow road, and block road. This figure shows there some problem of the road network. In Myanmar, many places has a one-end road. It is a one side is also closed, and narrow road. Narrow road is cannot enter the vehicle. There is a very narrow, very small, wide to enter the vehicle. Something is broken by close. So this is the road close. Now we consider only the bad condition of the road is one-end road, narrow road, and closed road. According to this situation and this condition, we consider to develop optimal finding system for emergency vehicle. It is such as a fire vehicle, police vehicle, and ambulance. And that time, I would like to express what is the optimal route. Optimal route is there between two locations. It is an incident location and destination. It's a service center or some rescue center and hospital or something like that. These two locations can be go safe and convenient road along there this way from one place to another. Then we developed a system of optimal route finding system. This figure shows the overview of the proposed system. Firstly, we collect the information of the incident place. Incident place is contained there as a location information, and then we identify that this location by using the Google Map and some map. After then, we find the close emergency service near the incident location. After computing the close emergency service location, and we find the optimal route calculation will be started. For this research we consider for the comparison of the original method and proposed method. This system is based on the web application. Let me explain about how to generate the road network database of Yangon. For this testing, we consider the Yangon road network because this Yangon road network is consist of a lot of the close road, narrow road, and some of the one-end road. The data sources from the Myanmar Fire Bridge, Myanmar Fire Department, and a land organization, Google Map. And then we using the GPS device of the government extra 10 device. We collect the data of road and some of the hospital, clinic. This one is the 85 hospital and clinic, 41 fire station, and narrow street, location of the close road. And we collect the latitude, longitude of this location data. And then we doing some identification of this collection data of network of Yangon region. We fix some junction point and something of node place is, we collect the number of node place is there, 554,048 number of node. And then we consider for the edge between the link of this node is not including the close road. One side road is number of edge is drawing there 131,209 edge. So this creating a better map of Yangon road network data analyzing and adding the spatial data information are performed by GIS. Open source package of GIS, post-GIS map, and GIS server are applied for this data collection. Let me introduce about our digital algorithm. Initially, digital algorithm is there, how to say, this is a blind search algorithm, only consider from one node to other, remaining node, they find that they are measurement and distance. But our modified digital algorithm is considered the first initial node and they are neighbor node. And then we computing of the nearest neighbor and find the measurement. For this algorithm is firstly, we consider the source node is firstly, distance of source node is the 0. And other of the source nodes from other node distance is also set in infinity. We consider the set of all nodes in graph until this is true is not empty. We find the distance of from source node to other nearest node. And there has some distance is smaller than the current distance. We put this node is replaced to the source node. Then finding repeatedly this algorithm, and finally we get the sum of the shortest path. Let me explain about the impact of the proposed system. We can how to use this proposed system. This system will help the user and business to recover the safeness and convenient way and direction between two any point. This is a location or some service on the road network of Google Maps. It is also deployed to such nearby refugee area and carry the best rescue route to evacuate people from the dangerous area. It will provide to develop the partial sequence route algorithm for the trip planning mobile application in ASEAN heritage region. This system also helps to reduce the delay caused by weak infrastructure road network for emergency vehicle. Furthermore, the proposed approach of optimal route finding system can be applied to various kinds of application in social network. This shows there some experimental result. Firstly, first figure is show there some information getting and put the some incident place, and then find the nearest location of the emergency service. So the second figure is show the nearest emergency service. And then result of optimal route map. After finding the 3 closest and 3 nearest emergency service and finding this or choose of the 1 emergency service and how to go the incident location. So using our proposed modified disaster algorithm. This figure showed that there is some route of the from incident location to destination. Let me conclude my presentation. The optimal evacuation route estimation algorithm is developed for complicated and structural network of Yangon based on modified disaster algorithm. It will be reduce the risk of emergency situation and save the people's life. The optimal evacuation route of vehicle is predicted. The closest emergency service location are examined for incident place by using geographic data and display the route result with detailed direction. The proposed work will have emergency recruiting directly to reach the incident location in short time, save their life and property. The proposed algorithm will reduce the memory consumption and the processing time. On integrating the real-time road traffic condition obtained by IoT sensor will be considered improve this proposed approach. Okay, thank you very much for your attention.
Thank you very much, Dr. Myint. So may I ask if any question from the floor, please?
Yes, yes.
One question.
Thank you for your presentation, Professor. I would imagine that. Can you go to the last slide?
Yes.
The one. Yeah, I would imagine that the last point is very important. Because the dynamicity of the real world environment, it plays a lot of crucial role in order to get the correct accuracy,
yes,
right?
Yes.
So it's pretty important. But why don't we take that as part of the proposal? Why? Because it seems like when you say that it almost like you don't want to do it. Or on getting the real time. We consider. But I would say that it's very important part. Don't you think so?
Yes, yes.
Do you
It
plan?
is really how to say this is the optimal route estimation and optimal route finding algorithm is will be used at the some how to say some trip planning and something like that. It is a bar routing how to find that this is a good way and from current location to destination, how to using which loop is we will use. So this is a finding for the bus route, and some is the visiting loop, and this is based on the graph theory. So we can use another optimization problem. We can use this as the same things. Yeah.
Okay, thank you.
Any more question? One more question, please, if any. Okay, so thank you very much, Dr. Meme-san. So next, I would like to invite Mr. Thayheng from Cambodia Academy of Digital Technology, Cambodia, to present about the indoor human detection and identification using commodity Wi-Fi. Mr. Thayheng, please.
Thank you very much, Dr. Sethserey, for the floor. First of all, good afternoon, and thank you to ASEAN IVO committee for giving me a chance to present about my proposed project idea on for this forum. So today I would like to present about our proposed project on indoor human localization and identification using commodity Wi-Fi. So let me introduce some background on why is it possible and what is the background behind the idea of having this project. So radio frequency is something we take for granted as it cannot be seen, obviously. But then after however, we cannot see it's transmitted, it's being around us from day to day and every day. And it's get transmitted, reflected, scatter around the object in the area, in the environment and all of that. And that is something we can get with the information at the receiver. So this is something that can lead to the possibility, what if we can get those signals, and then what if we can get some information about the environment regardless of how the radio frequency is being propagated in the environment. And another thing is that why are we considering of using commodity Wi-Fi? Because recently there's a lot of, well, we can see a lot of Wi-Fi router. I mean, the home one, the gateway used one, has been used in many in almost every household in the urban. So this is something we can consider of what if we can use those signals from the Wi-Fi we are having at our household to actually implement this project on using this ready installed infrastructure to do this. Another benefit to using this, regardless beside sensor-based such as video camera and all of that, is that Wi-Fi is a passive method which can be used in both in line of sight and non-line of sight, meaning you can go beyond the room and you can still detect it. However, in my presentation, it will be only focused on the indoor environment. And another thing is that using this technology, the user is not required to be mounted to any device. However, I like to mention that it is not the competition with the mounted device on sensing to our smart device. It will be a complement to those systems. So the purpose of this project is to build an accurate, non-invasive sensing application for localization and identification problem. So localization probably regarding how a human interact in an environment, and identification regarding the activity, also the authentication purpose. So let me just quickly, we will not go into detail on this enabling technology, but OFDM is one of the main technology that lead to the purpose of having this this project. And MIMO, another very important technology that lead to this as well, regarding having the multiple input, multiple output with having a multiple antenna on those wireless communication device. And another thing is CSI, which is obtained by the OFDM technology. CSI is the information that we get once the radio frequency, once the signal is being transmitted from the transmitter, and at the receiver side, you can get those CSI information. It's the channel state information of those small frequency in the wireless communication. And I just another one is to point out is that CSI is being used in multiple way, in one of which is if we use it in a time series way, it mostly used for identification purpose on how we walk, how we fall onto the floor and all of that. Those kind of information, when the signal is propagated and received at the end device, it's tell a different story. So this is the general method, because in this project we will be using both of the method to produce both localization and identification problem. So first of all, there will be you need an input. Input normally it will mostly be the channel state information, but one of the problem in the input is that the device have to be in the same network, I mean the wireless communication network, to receive those data, because channel state information cannot be received by the outsider. So that is one of the problems, is because if we are talking about unaided or maybe a non-cooperating device that is not in the network, it's not possible to receive this information. So there is another problem in that part, where how can we use another receiver or the outsider device where it can actually send the signal being propagated into it, and then calculate the channel state information with whether it is not in the network. And then moving to the signal processing part, there'll be three main methods, which is noise reduction, signal transform, and signal extraction. These three methods is used very intensively, although it really based on the application that is being applied. For example, in the localization problem, we will have a very intense noise reduction, because this kind of information is very sensitive to noise, that in order to retract those information. But for identification problem, noise doesn't matter much, because it mostly an add-on or just a reduction a little bit on the amplitude and the phase of the radio frequency. But that's also add the uniqueness to the propagated signals that we can identify using machine learning method. And going to algorithm, there will be three main currently in the current state of art solution in this area of application. There's a modeling based, learning based, and hybrid. Modeling based is refer to the part where we do actually calculate the location based on some information such as angle of arrival, time of flight of the propagated signal, and all that. And learning based is mostly involved using deep learning to do identification problem. So mostly when it comes to identification problem, mostly used in machine learning based algorithm, and sometimes hybrid, because some identification problem are sensitive to noise, but it's not very as sensitive as a localization problem, and which will lead to the application level where we have the localization of the people. It can be a 2-dimension x-y in a plane, and also in a 3D dimension. And let's come to the input data. So for this one, I will introduce a little bit on the tool where we can use to extract those information for the cooperating device, meaning the device which are in the network itself. So those tool CSI tool and ASERO tool, ASERO CSI tool, which developed by one of the university in Singapore. Both tool can be operated at 2.4 gigahertz and 5 gigahertz. So this is the most used software that we can use to put in the receiver to extract the CSI information. But for, like I mentioned earlier, that for non-cooperating device, it will not be possible to using this these two tools. So this is something we are looking into as well. Moving to signal processing in this part, I would like to mention regarding how we can use those information in time domain signals and in frequency domain signals. So in time domain signals, like I said, mostly we use for identification, because in time domain, we usually use machine learning such as time warping or Euclidean method to really identify to compare how the signal being propagated. So it's require annotation as well on this identification problem. So one of the heavy weight in this work is to annotate and knowing that when we set up the experiment and the people is in the room, and then we have to wait 2-3 seconds to annotate that, okay, there is a people during this time, and then the CSI will be able to tell that during this time what is the uniqueness of the propagated signals to really identify that there is people in this room, and for the frequency domain, mostly I used for human localization and tracking, where we calculate the actual positioning, time of flight, how far it is. And one of the methods is also using received signal strength, where we can identify the strength of the signal from the transmitter to the receiver to really know the furtherness of the object. Let's move on to different algorithm where we can use for the localization and tracking and identification. So for localization application, mostly are modeling based, and the two main methods that we usually see are angle of arrival, where this also based on the router as well, because some reception you don't get the angle of arrival because you only have one antenna, but you also get, but it's not very accurate. So the resolution is quite big in terms of that. So mostly there also a method where they propose a multiple antenna reception so that we can calculate a more precise angle of arrivals and also time of flight. Another for algorithm on identification, mostly using machine learning and most binary and multi-class identification. For example, whether for one of the model on knowing that the human is falling on the floor. So for this kind of application, we can just use binary classification to identify the unique signals of a person being fall or standing. I will move quickly a little bit. So here are some of the promising application: localization authentication system, vital sign monitoring. This is regarding the healthcare system. Also gesture recognition, one of the examples you see in the pictures, where you can just do some sign, and then the uniqueness of the propagated signals can tell whether it is what is the hand signal you are doing. And there's also human activity recognition, whether you are running, you are falling, or you are walking in the room in a way. So here are some challenges and open opportunity in this area. Right now, they coexist the robustness and resolution, because the resolution right now is quite big. The open opportunity for this kind of research also in the field of multiple scenario, multi-data source, which is also part of IoT source, where we can have it joining the IoT system. And while sensing for other species, maybe we can detect there's an animal in the area and somehow. And yeah, so this is the end of my presentation. Thank you very much.
Thank you very much. Okay, so may I ask any question from the floor? Okay.
Thank you very much for your interesting presentations. Recently, there is a new method for indoor human localization and identifications using Wi-Fi, light fidelity. What's your opinion about this? Rather than compare using Wi-Fi compared to Wi-Fi, do you have any opinion about that?
Wi-Fi is sensitive to light, but Wi-Fi is not sensitive to light. So whether it is dark, mostly it's Wi-Fi, not Wi-Fi. I mean, radio frequency in general is more robust when it comes to environment attenuation. That's why, and one of the reasons we are using Wi-Fi is because of the infrastructure that we already have with this kind of this kind of device. So yeah, that is why we are considering of using Wi-Fi. However, I have to say that although Wi-Fi is something we consider, it's very difficult because there are many now there's Wi-Fi 7 right now, so we also have problem with the interoperability with the different version as well. I think, do we have another?
Thank you very much for the question and the answer. So now we finish the second presentation and we move to the third presentation about the blockchain development to enhance the performance of logistics service provider networks. So may I invite Mr. Dr. Suryan Chumtanachais to come on the slide.
Good afternoon. My name is Suryan Chumtanachais from University, Thailand. I would like to present the project related to the application of blockchain technology entitled Blockchain Development to Enhance the Performance of Logistics Service Provider Network. Logistics services account for the majority of ASEAN trades, such as cross-border sales. From 2020 to 2021, ASEAN cross-border sales increased 11 times, particularly reflecting the ASEAN economy from the COVID-19 pandemic. The logistics industry is made up of several parties who work together to form a complex logistics service supply chain that is plagued by the main issue of information loss. Due to the large number of supply chain participants, many researchers believe that blockchain can accelerate the issue of information loss from the beginning to the end of the chain. Moreover, since the implementation of blockchain technology in the international logistics company, companies have reduced logistics expense by approximately 25%, resulting in outstanding performance in transaction cost reduction. However, the blockchain technology is still prohibitively expensive for small businesses. In this project, we will look at blockchain as a building block to create a prototype blockchain for logistics service supply chain, with the goal of improving the efficiency, trackability, and real-time sharing in logistics service industry, pertaining to the local small and medium logistics service supply chain to drive the ASEAN economy. This study contributes toward enhancing small and medium logistics service provider, or LSP, knowledge on blockchain technology, and kickstart the blockchain adoption in order to reap the benefits of disruptive technology in their logistics business operation. For the logistics business operation, begin customer service of the LSP receive a record detail from the customer or the cargo owner. The detail of information is distributed to the transportation unit of the LP. The transportation unit considers the availability or suitability of the company's truck, plan delivery to the and provide detailed job information to design truck driver. On the other hand, They order the transport work to subcontractors, transportation provider. Information about the job is forwarded to the subcontractor. Subcontractor truck driver. Truck driver of each firm will receive the information related to the loading and delivery of cargo to bring cargo from the loading point to the destination according to the customer requirements. For the purpose of scientific and technological blockchain method, first consider for the following blockchain feature. Blockchain transaction takes place with a peer-to-peer network or a decentralized manner. The peers represent the network participants with a key blockchain component that their peers hold the smart contract and ledgers. The smart contract or chain code is the code that has access to and may answer ledger and is typically invoked by user application external to the blockchain network. Blockchain can be viewed as a block link where access of transaction is contained in each block. Every block encode its hash value with its unique ID. Each block is linked to the ones before its parent block, forming a chain that can be tracked back to the initial block. The second, here are the primary technology that we will use to develop the prototype blockchain model, including the Hyperledger, Node.js, and Bootstrap. For the implementation of method related to the business operation of logistics provider, first peer 00 first ask for the transport to peer 01 with transportation of the information. Peer 01 creates transportation query and share it to peer 03 with job assignment information as one choice. Another is peer 01 submits a work order to peer 02 with the work order information. Peer 02 then creates a transport query and share it to peer 03 with job assignment information. Peer 03 starts an assignment with the loading information, creates and completes the assignment with the important delivery information update. All peer, especially peer 00, can monitor and entire process in real time using online device to update the service status with the customer. Peer 01 and peer 02 can be tracked and track the truck status and use summary and history information to control and manage the fleet for more efficiency. For the scientific and technical impact of this proposed model, blockchain technology is suitable for collaboration and information sharing platform due to its main feature of decentralization. For resistance and transparency, because blockchain can overcome traditional client server system. Data sharing between parties is a complex process that is susceptible to a variety of cyber attacks. It is required to develop the blockchain model of data sharing and monitoring in the logic domains because most data is confidential client data. It will also be an important foundation for the development of Logic 4.0, which is linked to the principle of automation, integration, and intelligence. Moreover, for the societal and collaborative impact in this project, first, communications between LSP and their partner is a key driver in developing flexibility and collaboration capability in logic service supply chain context. LSP must process their customer to share useful information about operation and logic. And LSP, for example, can be developed an information monitoring platform to facilitate information sharing with its supplier and customer. Local LSP for stations must collaborate with extensive business partners who have knowledge source to provide value-added service to customers in the innovative ecosystem. The outputs of the project for new application of scientific, the proposed prototype model is working model that satisfies the basic functions of tracking and tracing system, which is a key indicator of the performance of LSP. It could improve the performance of the LSP blockchains by integrating the concept of Internet of Things and cloud technology for smart fish management. The outcome of societal and collaborative technology that be transferred to the company. As an outcome, the developer can be used this study as a framework for blockchain development in the logistics service domain. This may aid in the space of development. As a result, future development costs will be lower, and the use of blockchain technology in the relevant sector, particularly the local logistics industry, will benefit. Global enterprises deem blockchain technology critical. They make it a top strategic priority, whereas firms prefer a supply chain or partnership to increase their annual revenues. Blockchain technology is central to transaction performance and management, which will have a positive influence on future costs and service time. In conclusion, the project has examined the development of blockchain technology for the logistics industry, a user service sector that plays a key role in the development of countries such as ASEAN. The application of blockchain technology is realized through the concept of blockchain customization prototype model for small and business scale logistics service supply chain. The private blockchain platform of Hyperledger Fabric by integrating the concept of Internet of Things and cloud technology is a consideration model. The use of this blockchain-based technology is critical to improve the flow of information in the logistics business network and provide a higher performance of service cost and time to customer. That concludes my presentation. Thank you much for your listening. Do you have any suggestion or question, please?
Thank you very much. So may I ask you any question from the floor, please? Okay. Speaker.
How to differentiate from what they are doing? Maybe
Yes,
just to repeat, I think IBM, Microsoft,
Yeah.
or even Oracle, they are doing something along this line, blockchain for supply chain.
Yeah.
Yeah.
Furthermore, I would like to explain the concept of this project that we need to develop this blockchain technology to overcome the business of traditional system. From the best performance of blockchain related to the centralization, and it's make us for the transparency. And also, when we operate with the logistics service supply chain, this operation based on blockchain is related to the several company to make the same information to operate the supply chain. And in case of the sharing data along with the supply chain, it's very difficult to manage under the traditional platform. Such as the EDI, and that's maybe has before. One benefit of blockchain that they said can be overcome for this weakness that I explained, and I think for this technology will be important for the industry or enterprise in the future, because right now the big company, large scale company already implement for the blockchain, but there are limitations for the small and medium enterprises that we need to launch the knowledge of blockchain to them and need to kick off this benefit technology to them. Thank you.
Okay. We have 2 minutes if one more question If any question, we can take one more question. Okay.
Take into account, if you take into account the government regulation, for example,
Yeah.
in this work, that's number one, and then number two is how do we maintain the standard?
Yeah.
I think if many regulation, maintain the standard in order to have a very good blockchain technology. Yeah.
Thank you very much. From our project, this is the prototype model that try to launch to the small and medium business. Deeply in the detail of the develop, we first ask to the company about their requirements and their regulation that they do the business right now. And we get the information on requirements from them to develop the prototype model first. The limit form of the prototype model operates only the network of logistic service provider, and maybe in the future this blockchain technology maybe can exchange to another concerned party, such as the government. For example, for the custom, when the logistic service provider move the cargo cross border. I think if this blockchain can show the performance when we kick off this prototype, the government that may be related to support the business, maybe more have benefits that to support to develop the blockchain technology for the small business in the future. Thank you.
Thank you very much. So now it's time's up, and thank you all the three presenters. Let me conclude the session. Thank you.